And we're live.
Great. Well, welcome everyone. And Benjamin, I guess we're back at it for doing our IoT Hangouts. And we've been away for I don't know when the last time we was, but I've been enjoying the summer, and I hope you have in lovely southern France.
Yep. And well, I also went to Scotland, which wasn't as sunny, I guess, but yeah, it was nice. Nice summer
It's,
so
it's
far.
and wonderful food in Scotland, I'm sure.
Yeah, yeah, actually, yeah, good
Or
meat.
whiskey at least. So, so we have today we're talking with the people from Bitreactive, which is doing some really cool tooling for IoT, and I think on the tools we're just starting to see the innovation coming on kind of getting better developer tools to make it a lot easier for people to put together IoT solutions, and I think Bitreactive's got some really interesting stuff. So Frank, why don't I let you introduce yourselves and start, and maybe you can kind of introduce Bitreactive, and we can get into what your solution is, and hopefully some interesting demos too.
Okay, so hi, my name is Frank Alexander Kramer, and I'm today with Linda Gunavan.
Hi.
She made the co-op and the Cura building blocks that we'll
Wow.
talk about later. So she joins us today. And we have Anna.
Hello.
Welcome.
And now, just briefly, we have a tool called Reactive Blocks. And Reactive Blocks is a Java-based tool integrated into the Java development tools in Eclipse. And you use it for building applications in the IoT and M2M space. And you may ask, what kind of applications? Those that run on gateways. So
Okay.
wherever you would use Java and especially OSGI, so that size of gateway, um, Reactive Blocks is the tool. The nice thing is with Reactive Blocks, it's called blocks, so it's making applications from building blocks.
All right.
We are using a UML notation, so a UML activity diagrams or our flavor of it. So it's a graphical tool. However,
Okay.
and I say that without any break in between, it's not the kind of graphical tool that only lets you specify what it predefined in graphics. So you're still programming in Java. So you're
Okay.
very
So
close.
it's a useful tool.
Sorry?
So it's a useful tool.
Yeah, well, I'm not against any graphical tool, but I have to say it immediately, so you don't leave the programming space. So whatever you love to program and those lines of code that you still want to write, you still write them. You're not
Right.
that. But the tool generates automatically all the kind of code that you really don't want to write and that you usually cannot write very good after all experience. The one that has to do with concurrency.
Okay. Good. So do you want to show us a demo? Do you want to show us some? I think you had a few slides that you wanted to show us first, or?
Yes. So
Okay.
we made a demo today, and you might have seen it on our blog and it went through Twitter that we experimented with blocks for Californium for co-op.
Yep. Yep.
So we are part of the Eclipse IoT Working Group, and we are of course very interested in all the technology that is done there, because that's exactly the technology that we want to make building blocks for that you can so use in applications.
Great.
Okay. I show you first the running demo, and then I show you how it's done.
Okay. Perfect.
Anna, why don't you help me? So we have two Raspberry Pis here.
Okay. So tell us about the Raspberry. Let's talk about the hardware first.
Yeah.
So what flavor of Raspberry Pi?
That's the model B+. So you see here it has the many pins, the new ones, and it has 4 USBs, which is very nice if you, in addition to a Wi-Fi and a Bluetooth dongle, you also want to put in the keyboard and the mouse, for example, at the same time. So a very nice improvement. And on top of it, we have added the Berry clip, which is a very, very nice and very simple extension board. So it has 6 LEDs, and it has a buzzer, as you will hear soon, and it has a switch. So not very advanced, but it's very easy to use, and you can use it very nicely for making prototype applications.
Okay. Great.
Um, okay. Oh, I just got aware that the SD card is out, so I have to move it in, and I think we have to.
Yeah.
Yeah.
Oops.
Okay. Let's see. So okay. So why don't we use the other one? So what we did, we made an application that can control the LEDs and the buzzer and the switch in Java. And then we added our building blocks, one that uses MQTT for sending the IP address of this port to the other one and vice versa. And then we added a building block for co-op so that the switch on one board can control the buzzer and the LED on the other board. Okay? So,
There's also a building block for the GPIOs, I guess.
yes, exactly. So I made a building block for the berry clip, and so I have building blocks also for the LEDs and for the buzzers. Now I'm just asking, are you trying to restart it? Okay, Linda is restarting this one while I messed it up with the SD card. And while
Enjoy some live demos, right?
yeah, well, we should have put it into a box actually. Let's see. I'll show you how we actually made that building block. Let's see, and then I'm sharing my screen. Just a second. Okay. Do you see my screen now? Wait, share. Now
We do see it now.
okay. So let's see. Okay.
So this is Bitreactive that we're seeing now, or sorry, would have? No,
Yeah.
This is
So
okay.
I would show you now how you actually create a building block and really from the ground on. What you see here now is the code that we use from the Pi4j library in order to talk to the LEDs. So you get a nice representation of the GPIO, and you can set them to on and off. And in order to control a LED, I have to write two Java methods, and I still do that in reactive blocks. So I write one Java method for LED on and the other one for LED off. And the integer is the number of the LEDs, so which one of the 6 LEDs. So I write this Java code, and then I'm encapsulating this in a building block. Right? You can see here on the right side, I have represented these Java operations LED on and LED off, correspond to exactly the Java code here. And I'm adding here the parameters for which one of the LEDs I'm going to switch on or off. So that's a building block.
Okay.
This one is very, very simple. It's almost the most simple block that you can do.
Sure.
Other blocks, for instance, that encapsulate MQTT or Cura, they are much more complex. However, from the outside, these building blocks usually look pretty simple. So you see here the one for the LED. Of course, it's on or off. I have a P here. That means it's a parameter. That's where I can set which of the 6 LEDs this is responsible for. Right? And then I'm building the application around it. So I'm adding more building blocks. And now you see we have also added a buzzer. Works pretty much the same way as the LED. And another building block, this is the one for Californium. And we made a blog post about it where we explain why we have chosen to do building blocks like this. Briefly, Californium is also an Eclipse IoT project, and it implements the co-op protocol.
Mm-hmm.
And in co-op, you can communicate between small devices in a way similar to HTTP, where you have get post methods, and you represent devices by resources. And we made one building block for what we call a Boolean resource, so one that can be switched on and off, obviously, like a buzzer or a LED, right?
Right.
And when we switch on the system, we start here at the initial node. We give this resource a name, and we start it with the name as a string, as input. And from then on, we are listening to incoming co-op requests. And once they arrive here, we are pushing out the Boolean, which is then either true or false. And depending on if it's true or false, we switch on or off the buzzer. and at the same time we are switching on and off the LED. Of course, we could have made the LED and the buzzer available by separate resources, but the idea is now to have a simple application that beeps and lights up at the same time.
Yep. Okay.
Okay. So, and briefly, we did the opposite for the other way around. So we have a building block for a Boolean set request that's sending out a request. So switching on a LED. So that's in a way the sender part. Whenever we click the button, we are switching on the other LED and sending a request to the other Raspberry Pi. And then
and so do people build up a library of these building blocks, and kind of so you kind of build up the co-op building blocks that like all your developers on your team could reuse, and so you're only doing it once? Is that the idea?
Exactly. So everybody can also, if you sign up, then you can get access to the building blocks of co-op. It's actually a link in the blog post to the library, so you have to join the team, and then you can download these building blocks and experiment with them. For the ones with co-op, they are very early because we are experimenting. How should we expose co-op?
But in general, you have a library of different building blocks for people to so I think you mentioned MQTT and Cure, so you have building blocks around those, and I'm assuming the other IoT devices and standards that you've got pre-made building blocks.
Exactly. So I can also share my Eclipse with you. Let's see. We have this one. Here I actually have all the libraries.
Okay.
So let's see. This one is the one for buffering, which is very important. And there we have, I hope you can see it, one that includes general co-op blocks, so co-op client, a co-op resource, and a co-op server.
Yeah.
And then we have, for instance, building blocks for MQTT, for publishing and subscribing. We have some building blocks for Modbus.
In OAuth, it looks like. Yeah.
Yeah. Cool. And we have, for instance, oh no, I'm looking the set and get variable via co-op. So that's here a specialized library for co-op if you have these resources that look like Booleans. And obviously we will add more in the future for strings and so on. Okay.
Yes, and then of course people can make their own building blocks. So it's not restricted. It's not like we have to make them. Developers and encourage developers to make building blocks to share with other developers, and yeah, it's really neat.
Yep. Good stuff. And then when you're building the applications, so how do you deploy it out to the Raspberry Pi?
Yeah. The code generator generates a complete standalone Eclipse project.
Mm-hmm.
So it copies all the resources it needs into that project, the jar files, and everything else that you need for that application. So you have a self-contained Eclipse project. It is not coupled anymore to our tool. So it's pure Java code. And you can then use that application and either pack it as an OSGI bundle or as a runnable jar.
Okay.
So now for the Raspberry Pi, for this application, I was just exporting them with the standard Java wizard as a runnable jar, and then with scopy onto the Raspberry Pi.
Okay.
But obviously, there are other options if you would like to have an OSGI container and then use other techniques for getting that OSGI bundle there.
Right.
Okay. Now, Linda fixed the Raspberry Pi. It should be online now. Let's see. If Anna, if you hold yours.
Yeah, you have to go to your
If I click here, then
fingers crossed.
Oh yeah.
Yes, that was
So you see Anna's Raspberry Pi is blinking.
Do it again.
Yeah.
You see, yeah. You see
There you go.
Yeah.
And it also works the other way around.
Yeah. So then I can do the same thing.
Yeah, and it's
a perfect IoT example. There you go.
it doesn't do anything, but it lets you know.
Well, as you said, it's kind of like a Morse code application, right? You could start sending Morse code with it.
So the interesting thing here now is we are sending the Morse code or the commands for switching on and off the buzzer as separate co-op requests.
Okay.
Technically, of course, it doesn't make any sense of transmitting information that way, but it's a demo, of course.
Right. Sure. Good. So how do developers get going on Bitreactive? How can they get it? Kind of how can people start trying it out?
Simply sign up on our webpage. It should be fairly easy. You need to log in with a Google ID or a Facebook ID. That is because we don't want to manage a lot of passwords, and that's the idea we use for managing sharing.
Okay.
So once you have signed in, you get instructions how you install the plugin. It's actually an easy install via the Eclipse Marketplace.
Okay.
You can just search in the Marketplace client for Reactive or blocks, then it should come up. It runs on both Luna and Kepler.
Okay.
We have a lot of tutorials, also links on the site, where you just get started there. So ideally, you could use a Raspberry Pi because it's so simple to use. But there are also tutorials for the PC. So most of the examples also run on the PC.
Okay. And what type of applications are people building with Bitreactive? What's kind of the typical application that you're seeing?
Yeah. Typical applications is everything that runs on these gateways. So
Okay.
whenever you want to monitor something and send data into the cloud.
Okay.
And well, I said before that everything where OSGI and Java runs on is a typical candidate. So
Right.
it probably doesn't. You don't need reactive blocks if you just would like to program a sensor node that is very, very simple, where you have some lines of code and only, let's say, one sensor that updates itself. Then you wouldn't appreciate the tool. It is useful when you make applications where several things happen at the same time because it lets you model the concurrency very nicely.
Okay.
Why don't you show that greenhouse demo?
Yeah, so because the co-op Morse example was just for showing you how to get going, I can show you a more typical example, and what could be better for IoT than the official Hello World. In the IoT world, that's the greenhouse, of course. And we did the greenhouse, let me see.
So this is Benjamin's famous greenhouse.
Yeah, I
demo
think,
that yeah.
according to Benjamin, he invented it as the Hello World for the IoT.
Absolutely.
Yeah, I think
Say that.
we should give him credits for that. Let's see, I'm sharing my screen again. Oops. At least that's what I tried to do. Okay. Now let's see. Here you see a picture. That's from Embedded World this February.
Okay.
And we built this greenhouse demo together with Eurotech, who also are participants in the IoT group.
Yep. And doing a lot with Cura.
Exactly. So at that time it was still called ESF, but ESF emerged into Cura, the Eclipse IoT project. And this greenhouse, it managed a lot of resources. So it was a simulated greenhouse, so it was simulating the light, it was simulating the health of the plants by inflating this plastic cactus. And you could manipulate also the wind speed, and it could open the window here. It was very, very nice. And the control application was running on this gateway, Eurotech Relia Gate, and it used the ESF framework or Cura, and it was built with reactive blocks. And here you already see how the application looks like. It contains a typical number of building blocks of such a realistic application on the top level. I can show you some details. So here, for instance, in the upper left corner, we have the configuration handler. That's a service offered by Cura. So whenever I have applications, then I can specify which kind of configuration parameters each bundle has, or each application has, and I can monitor, or I can remotely administer them and change them. Whenever I do these changes, then I get a map of values, and we distribute these values in the entire application. There's also a communication framework that you can communicate as part of Cura that sits in that building block. So these two building blocks here are reused from the library. Then we have also application-specific building blocks. Here it's the simulator, which simulated the sun and the day during at the time during day. And here we have building blocks that were acquiring sensor data via Modbus, and the window down here, which was controlling the motor that controlled the window via Modbus, and some other building blocks that implemented some application-specific logic. So that's more the typical size of an application, right? And you see here, all these things can, in principle, happen at the same time. You still write the Java operations. Here, for example, we have one, and of course, inside the building blocks, there are several. Reactive blocks controls when these Java operations are called, but it generates the code for that, but you still write the content.
Yep.
And I have here an overview of the entire system. So you see these building blocks, they decompose on quite some levels until you get building blocks that are elementary and only contain Java operations.
Yep. Okay.
So let's go back to the camera. There we are.
Okay, well, I think this has been a great introduction to what you guys are doing, and so we'll make sure we have a link to where to sign up to get access to Bitreactive and your building blocks. And so is it like is it kind of, I know it's a commercial product, but is there like a free developer version, and then
yes?
So what's the upgrade path?
We have the free version, and with the free version you can build. You get all the features that also the commercial version has. It works for building blocks that you share. So you can build applications with building blocks that you find that are shared by others.
Okay.
And you can build your own applications as big as you like, as long as you share the building blocks with others.
Okay. Oh, interesting. Good.
So that's the difference between the free and the commercial version.
Right.
And what kind of IoT building blocks do you have on your roadmap? Like, do you plan on providing building blocks for new protocols, supporting other IoT devices? Is there anything you can share?
Yeah. So the ones that we made for MQTT and for Co-op, now the latest one, these are examples for building blocks. So everything that is happening in the Eclipse IoT Working Group, for instance, is a good candidate, especially, or it has to run on Java. So I'm looking with one eye, of course, on the smart home initiative. That's very interesting.
I was going to ask you about Eclipse Smart Home. Have you done building blocks around?
We did not yet.
Okay.
So at the moment we are focusing on Cura and Co-op and MQTT. But of course, everybody can contribute with building.
Yeah, I was going to say, yeah. So other people could do that. So.
It would be a nightmare if we would have to do all of them ourselves.
Yeah.
And it's an interesting undertaking to offer building blocks of your technology, because you also learn more about your own technology, how you would like to provide these APIs.
For sure.
Maybe that's worth mentioning because, well, we have the PAHO project, right, which implements the MQTT protocol and which offers an API. So why should we offer a building block of that? And the building block just would encapsulate the PAHO API. So we are not reinventing or rewriting or re-implementing the MQTT protocol, of course not. But we see that once you build applications, let's say that use MQTT for communicating some sort of data, but then use another protocol for communicating another kind of data. And also locally making operations and using Modbus for getting sensor data or controlling stuff, then these applications are getting very complicated, and you would like to build these applications like these Lego blocks, like these building blocks. And then it makes sense that the PAHO project is encapsulated as reactive blocks because it just gets simpler to integrate into these applications.
No, for sure. No, I think, like I said in the introduction, I think it's a really interesting approach, and what I'm finding is that kind of IoT. There's lots of hype around IoT and lots of things going on. There's not a lot of thinking around the tooling and making it easier for developers, and so I think this is a really interesting approach that you guys are taking. So thank you for sharing with us. And Benjamin, did you have any other questions for Frank?
No, I was about to move on to maybe some news, and we've been talking about the IoT Working Group. Well, some cool stuff has been happening recently, like in just a couple days ago, actually, Cura did their first code release. So, well, the source code has been available for a while, but now you can actually download a ready-to-use binary that you can install on your Raspberry Pi, and I'm going to share my screen very briefly. They basically, you go to eclipse.org/Cura, and you have access to the whole documentation and to the downloads.
This is a great website.
Yeah. That's we actually are very lucky in the IoT working group because many projects actually have very nice websites, and
Yep.
very easy to find the documentation, very easy to find where to download, for example, the latest stable version for the Raspberry Pi. So this is where you download the Debian package, and you basically issue a very simple command on your command line, and you get something very similar to this. This is a Raspberry Pi I have at home. So once you've installed Cura, you basically have a complete framework that comes with a nice web interface, and well, it's basically everything you need to manage your IoT gateway, manage the network settings, firewall settings, as well as deploy OSGI applications, like a greenhouse application, as we've seen earlier. This one is not implemented in Bitreactive. It's good old Java and OSGI code, but yeah, basically that's what Cura allows you to do. So I very much encourage you guys to check out the website, download the 0.7 version, and the Cura team is actually already working on 1.0 because, well, the APIs are already quite stable and the product itself is very mature. So that's pretty cool.
Yep. I think the other item I thought was quite important was it last week? So Deutsche Telekom announced that they were going to join the Eclipse Foundation, the Eclipse IoT Working Group, but also, which I think is great, kind of having a large European telco step up to kind of for open solutions. But I think more importantly, to their home automation solution, Kivicon. They said they're going to start putting resources into Eclipse Smart Home and have Kivicon. I hope I'm pronouncing it correctly. Use Eclipse Smart Home. So I think that's, Frank, kind of one of the reasons I asked you about Smart Home is I think we're going to see a lot more interest in that. I think having Deutsche Telekom behind it is going to be great. So so I think that's some important news for that. Benjamin, do you have it? We could also talk about conferences that we're going to, where we're going to be. Or?
Yeah, I mean, especially Smart Home, I guess, will be one of the many Eclipse projects represented at the next biggest conference is probably Java one at the end of September.
Yeah,
so
we're going to have a booth there, and I know you're speaking.
Yeah, we will have an MQTT tutorial. We will talk about all the cool projects that we have for building IoT solutions based on Java. And yeah, if you happen to be in the Bay Area at the end of September, come at the booth. You will see the many demos of Californium, Tahoe, Smart Home, OM2M, etc., etc. I mean, pretty much every Eclipse IoT project that has something to do with Java will be represented there. So that's that's one conference. And next week, well, in 10 days, there is also a big conference in Europe, in Berlin, the IoT conference. I mean, if you look at the program, you'll see that it's going to be very interesting. I'm talking there as well. Also, talking about our Java projects. I think Frank, you're there as well, right?
In Berlin?
Yeah. No.
No.
Okay. Nope. And what else, Ian? What other? Do you have
I think
conferences?
I think the one interesting kind of industry was item I saw was Samsung buying smart things, not smart home, smart things, but for the smart home industry, the home automation industry. And so it's I'm not sure if it's the first significant investment that Samsung's made in the IoT world, but it's certainly interesting to watch. And it kind of home automation seems like it's going to be an important battleground in one segment of the IoT industry, kind of with Google and Apple and now Samsung and Deutsche Telekom, right? So I think there's going to be lots of players. So be interesting to watch.
Yeah, definitely.
So, but I think that's it. I think we hit our half hour. It's good to be back doing these. We'll have to set up a schedule and kind of get some more topics. Frank and Anna and Linda, thank you very much for joining us. Actually, I think we'll see you guys at EclipseCon Europe for sure. If not before. For sure. Okay. All right. Well, thank you, everyone, and we'll talk soon.
Thanks for having us. Bye-bye.
Bye.
Thank you. Bye-bye.